Delhi Jal Board, a department of National Capital Territory of Delhi, responsible for entire Delhi's water supply and sewerage system. Bhagirathi is one such water treatment plant, designed and commissioned in the year 1983. The primary source of raw water is from Upper Ganga Canal through the intake at Muradnagar. The raw water flows through 2800 mm diameter gravity main to the Bhagirathi water treatment plant from Muradnagar. Alternative source of raw water to the Bhagirathi water treatment plant is river Yamuna by pumping from raw water pump house at Sangam, Wazirabad. Bhagirathi water treatment plant works on the proven conventional treatment technologies to provide quality potable water 24/7 to entire East Delhi, covering more than 40 lakh population. The water treatment plant consists of one bifurcation chamber, 8+2 clariflocculators and 40+4 rapid sand filters and other utilities for disinfection, chemical addition and storage. Administration building. Rehabilitation would strengthen the building and give new look interior as well as exterior. At ground floor, there would be contractors project, operation and maintenance office, reception, place for project manager, construction manager, plant manager, planning cell, execution and administration staff with pantry arrangement. First floor would be for Delhi Jal Board officials and conference hall, suitable to accommodate 30 participants. The building would have vitrified tile flooring, aluminium glazed doors and windows, interior wall finished by oil-bound distemper and exterior finish by Dholpur and Agra stone cladding. Also, roof waterproofing by APP membrane done over screed concreting. The building would promote green building concept. Process. Intake work at Muradnagar. Bifurcation chamber. Raw water comes from Upper Ganga Canal, flows through 2800 mm diameter gravity main to the newly constructed bifurcation chamber, which includes one electrically operated sluice gate of size 3000 by 3000, which shall have control over full flow, 6 electrically operated sluice gates before and after bar screens, 3 numbers PLC-based operated SS bar screens which removes floating materials, 4 motorized operated delivery valves to supply water to 8 clarifiers of 100 mgd and 1 motorized operated delivery valve to supply water to 10 mgd water treatment plant. An overflow arrangement is also provided to handle excess flow or to bypass entire flow during power outage or other emergencies. When Upper Ganga Canal is closed for maintenance, raw water from Sangam raw water pump house is supplied through 2 1500 mm pumping main to the bifurcation chamber. 24 hours automatic water quality and quantity of incoming raw water. The set desired parameters of raw water varies and falls below the acceptable limits. There will be warning alarm. If the same situation continues, the PLC system will automatically deliver command of stopping of raw water. Pre-chlorination system installed in new chemical house is responsible to dose chlorine in bifurcation chamber water as a disinfectant and prevent algae growth on water contact surfaces. Clarifier. From bifurcation chamber, water flows through 4 1200 mm diameter pipes towards respective inlet chambers. One additional 800 mm diameter pipe is also provided to supply raw water to 10 mgd water treatment plant. From each inlet chamber, water flows via 2 different motorized operated penstock gates through 2 divisional channels to flash mixers. The division channels have measuring flume to measure flow, coagulants, alum and PAC, which come from chemical house by pumping line, dose into the respective channel. Flash mixers consist of VFD-based electrically operated agitator to mix coagulants, alum and PAC properly in raw water. From flash mixer, water goes to clariflocculator feed chamber. From each dedicated clariflocculator feed chamber, water flows through 1000 dia CI pipe to clariflocculator. Total 8 numbers. Clariflocculators are available in the main stream of 100 mgd. In each clariflocculator, water enters through openings provided in central shaft. Water fills into the flocculation zone first, where slow mixing is done and flock formation takes place. Flocculation zone has openings at the bottom to direct the water into the settling zone, where settlement of flocks takes place. The settled sludge is scraped out by mechanical scraper from settling zone. The sludge from clariflocculator is collected into the sludge sump through sludge pipeline. The same sludge is pumped to the reactor thickener of recycle plant. From reactor thickener, the supernatant is recycled to bifurcation chamber, which minimizes water losses. The clear water from clariflocculators is collected into the peripheral launders. The collected clear water enters into the filter house via filter feed water channels. At the outlet of clarifier and prior to peripheral launders, water passes through independent gate, useful during isolation of clarifier for maintenance. Filter house. There are 2 filter houses in the main stream. Each would be with micro PLC based 20 rapid sand filters in 2 rows. Water passes through these filter beds for further treatment to achieve desired quality of water. Below the filter media, a grid of laterals collect pure water and transmit it to manifold channels, then further to filter control boxes, where flow control valves regulate the flow to maintain constant rate. From filter control box chambers, the filtered water flows to the underground reservoir through clear water channels. Chlorine is dosed at the clear water channels, east and west, to achieve complete disinfection before storing the water into the underground reservoirs. Under drain system with new motorized operated inlet, outlet. Backwash inlet, backwash outlet valves. The feature of micro PLC based filter bed is continuous automatic monitoring the healthiness of filter bed and also ensuring the execution of backwash operation without any manual interference. Loss of head and rate of flow. The backwash of filter bed is programmed in such a way that if loss of head is more than the set parameter, the system goes for backwash process. Also, in case of high turbidity in outlet of filter bed, the micro PLC system would automatically shut down the concerned filter bed and also send the information and alarm to main control room for necessary action. Filter house annex. Each filter house is equipped with PLC-based filter house annex for backwash water and air supply. The PLC of filter house annex would monitor the performance of micro PLC provided by each bed and also supply the water and air on requirement and request of micro PLC for backwashing purpose automatically. There would be provision of automatic dewatering pumps for dewatering the excess water. Clear water reservoir. The disinfected clear water coming from filter house, 2 of 100 mgd and 1 of 10 mgd, and stored in 5 numbers clear water reservoir through clear water channel. Each clear water reservoir would have motorized operated inlet and outlet gates for individual isolation of clear water reservoir. Clear water sump and pump house. Clear water from 5 numbers reservoir distributed to 2 numbers clear water sump. CWR number 1, 2, 3 are connected to CWS number 01 and CWR number 3, 4, 5 are connected to CWS number 02 for pumping to 4 numbers rising mains. In any condition, if the water level is minimum, the system would give alarm. If any precaution not taken, it would automatically stop the pump as per the program, hence preventing from dry run. And in case of rise above maximum water level, the system would also give alarm. There are 17 existing centrifugal pumps in clear water pump house, where serial number 1 to 7 of 12.5 mgd capacity for 45 meter head and serial number 8 and 9 are 7.5 mgd capacity with 45 meter head. Pumps from serial number 1 to 9 are in east side of pump house and serial number 10 to 17 are 12.5 mgd capacity for 45 meter head are in west side of pump house. The new installations of pumps are as per same division existing arrangements, where pump number 1 and 9 are at east side and pump number 10 to 17 are of west side of pump house. New pumps number 1, 2, 3 are pumps of capacity 14.3 mgd, 20 meter head driven by 3 numbers 200 kilowatt LT motor. Out of 3, Pump number 3 is variable frequency drive to maintain the discharge as per variable requirement under specific range. Pump number 4 to 17 are of capacity 13.9 mgd, 36 meter head, driven by 350 kW HT motor. The all 17 pumps would be commonly connected to common header. In existing system, there are 5 mains, out of only 4 are in operation. Greater Kailash, Tahirpur, Shahadra and Jalvihar. The civil line main is non-operational now, and in new setup also, same 4 will be operational. The elimination of civil line main from the system will help to have additional 3 pumps of serial number 15, 16, 17 in new operation and add up in standby capacity. The new work includes rehabilitation civil work for the entire building and foundations. There would be provision of automatic dewatering pumps for dewatering the excess water. Settling tanks and dirty backwash recycle. Dirty backwash from both filter houses flows through 1200 mm diameter pipe by gravity to the inlet chambers of 2 30-meter dia settling tanks. Here, the settling sludge shall be scraped out by scraper and overflow shall be separated and directed to backwash recycling pump house. Recycling pump house goes to bifurcation chamber. The settled sludge shall be directed to the reactor thickener after installing scraper in the settling tank. New system would be well equipped to the inlet of settling tank. There would be provision of automatic dewatering pumps for dewatering the excess water collected through seepage of gland packing and priming pumps for priming the pumps in case of negative suction head. The new work includes rehabilitation civil work for the entire building and foundations. Sludge pump house. The sludge collected from sludge line under clariflocculator is collected in sludge sump and pumped through 4 running and 3 standby centrifugal pumps to reactor thickener through 600 mm dia main. Chemical house. New LM godown and chemical house would be constructed. The new LM godown would store 1000 MT of LM and chemical house would be equipped with all machineries. The LM dosing tank, LM saturated tank and PSC dosing tanks, 6 mgd sludge recycling plant. Sludge collected from 100 mgd plant through 600 mm dia pipe, 10 mgd plant through 200 dia pipe. Dirty backwash settling tank, newly proposed. Filtrate from sludge drying beds through 150 mm dia pipe by and centrate from centrifuges through 150 mm dia line to the inlet chambers of reactor thickener. Here, after thickening process, the supernatant goes to existing flash mixer of 10 mgd plant and would go to new bifurcation chamber after rehabilitation. Thickened sludge is directed to sludge drying beds or centrifuges or both according to the quantity of sludge generation. There is also provision to bypass the sludge in case of overloading through drain outside of the plant. The sludge from reactor thickener through on-line sump is pumped by 4 centrifugal pumps. There is provision of taking it to either drawing bed, total 9 numbers, or centrifuges, 3 numbers, at centrifuge building. Filtrate from sludge drying beds is collected in filtrate sump and pumped to reactor clarifier by 3 numbers submersible pumps. The concentrated sludge from sludge drying bed is removed manually and disposed of as advised by Delhi Jal Board officials. The sludge from centrifuges is dropped down in tractor trolley and disposed of as advised by Delhi Jal Board officials. The coagulant called polyelectrolyte is pumped by reciprocating pump from chemical house in thickener to accelerate sedimentation in its flocculating zone. Lime is also added to reduce acidic properties of sludge water through chemical house.